Voltage, voltage, voltage. All right, now we are ready to talk about what voltage is. Oh, you've heard of volts. You heard me in the last video. I was talking about batteries, talking about 6 volts, 1.5 volts, talking about 9-volt batteries. We're a 12-volt battery, car battery. We're talking about batteries have voltage. What does that actually mean? It's actually quite confusing because voltage and what's called electric potential energy used synonymously. They're not quite the same, although you kind of can use them synonymously and get away with it. Let me show you what I'm talking about. When it comes to voltage, we have to first talk about electric potential energy. So electric potential energy, I'll go PE, well, let's do this. PE, electrical, is equal to, oh, wait a minute. Actually, before I write that out, let me go PE, gravity. Gravitational potential energy. You know that something has potential energy when you lift it up, okay? You let it go. It's got potential energy, okay? You've lifted it up. And the equation for potential energy in a gravity field is mgh. Okay, now this is analogous to electric potential energy, but we don't have mass. Like, it matters how heavy something is when you lift it up to give it potential. The more massive it is, the more potential energy it has. When it comes to electrical, it's all about charge. Yeah. So when it comes to electrical potential energy, if you don't have something which is charged, there's no electrical potential energy. If you have something which is like Switzerland and neutral, we are the Swiss and we will stay out of everything. Yeah, those people, nothing happens because if you're not charged, you can't have any electrical potential energy. You have to have something which is charged. Okay, so charged, and then we have to have a field. This represents the gravity field. Of course, with electricity, we all know that the E represents our field. And height is how far above, maybe the ground that you lift something to give it gravitational potential energy. With electrical potential energy, it doesn't have to be lifted above something. It can be lifted sideways. Like I have a positive here and a negative here and sideways. They have potential energy. This thing wants to the negative, wants to go to the positive. That's potential. So we give it a D instead of an H because it doesn't have to be vertical. Okay? Gravity, got to be vertical. So you can see the equations actually are quite similar. They don't look alike at all. Well, okay, Billy, come on. Don't be so angsty. They are. I'm using my Jedi mind powers on you, Billy. They are. Oh, I see it now. Yeah, exactly. So this is our electrical potential energy equation. We need to have a charge. We need to have the strength of a field. And we have to have, how far away that something is. So let's say, for example, I've got this positive plate down here. Maybe it's a piece of metal that's had been stripped away of some electrons, so it's positively charged. And I take this negative particle and I put it here. There is potential energy here, people. Oh, and I could do this sideways as well, just to show, just to demonstrate that I'm not talking about, when we have, I'll put the negative here. There's going to be potential energy. This wants to go here. This wants to go here. It doesn't have to be vertical like it does with gravity. It can be like sideways. This wants to go here. When you have potential energy, whenever something wants to go where it wants to go, you have potential energy. What? Whenever, like this negative wants to go here, and it can do that, there's potential energy there. When it gets there, once this negative is sitting here on the surface, there's no more potential energy anymore because it's where it wants to be. If you're where you want to be, there's no potential energy. If you're not where you want to be, there's potential. Okay, now, so that's potential energy, voltage. Voltage is very, very similar, except voltage says that it's the amount of, let me give you the equation for it. This is one version of the voltage equation. This is the most common one here. Voltage is E times T. You can see that this portion is here. What happened to the Q? Exactly. That's the difference. The difference is it doesn't make any difference what the charge is that's in this field. So here we have a field being generated by this out of the positive. Remember, out of the positive, we have this field being generated. It doesn't matter what here, if you wanted the potential energy of this particle, you need to know the charge of the particle. Because that's what it says. With voltage, you don't need to know the charge. It doesn't matter. Voltage is the amount of potential energy. I'll write this down. Amount of potential energy per unit of charge. It means the amount of joules. Okay, because remember, energy is measured in joules. Remember that? Yeah, joules. Joules and then charge is measured in coulombs. So voltage is joules per coulomb, and what that means is how much energy there is per coulomb of charge within the field. So I could have in this field here, I could have a 20 coulomb charge. That's pretty charged. And I could have a 2 coulomb charge. Now, do those two charges have the same amount of electric potential energy? No. No, because that's bigger than that. So potential energy is different. However, the voltage is the same. The voltage for U and U means the amount of joules per unit of charge. So we divide by the charge, and that eliminates the amount of charge. You'll have more joules, but it's per unit of charge. So in other words, what I'm trying to tell you is that when it comes to voltage, it doesn't make any difference what the charge of the thing is within some kind of a field. It's within an electric field. If you put any charged particle in there, it's going to experience the same amount of voltage as any other charged particle. So we can think of voltage as being potential energy. It's not, but I would say close enough for government work that when I talk about voltage, or you hear somebody talk about voltage, you're talking about potential energy. Okay, you're talking about potential energy. So here's what we got. So let's say we got a 1.5 volt battery and a 12 volt battery. Which one of those two batteries can do more work on a charge? Well, the 12 volt battery. It doesn't matter what the charge is. I said a charge. I didn't say what kind of, I just said a charge. Both of them will be able to do work on a charge if you move that charge in the field. Okay, move the charge in the field. Just like you take something and move a mass in a field, okay, there's some work being done. Work, I'm getting so tired, it's exhausting lifting this up. I'm doing work. So if you were to move a charge through a field, there's a certain amount of voltage in that field, and no matter what the charge is, it'll experience the same amount of voltage. So we can think about voltage and potential energy as being the same. They're not quite, but we can think about them as being the same. So if I say voltage, you say, all right, it has something to do with potential energy. Yes, it does. It has something to do with potential energy. Okay. All right, so voltage is the word that you'll hear associated with a battery. The more voltage that a battery has, the more work it can do. The more work that it can do, the bigger the job that it can do. But you know that, because a 12 volt battery can certainly do more work than a 1.5 volt battery. All right, so voltage and potential energy. Not quite the same thing, but we can think about them as being essentially the same, or think about them being the same. So voltage is the amount of, what I like to call is the amount of push. How much pushability does your battery have? If you're 12 volts, you can push on those electrons harder and move them better, easier than a 1.5 volt battery. 1.5 volt battery can still do the job, but 12, more voltage, more potential there. All right, now, voltage is sometimes written as, you'll see these words all mean the same thing. It can be a little confusing. But voltage can also be seen as called electric potential. Electric potential. Notice I didn't say electric potential energy, because again, they're not quite the same thing. So voltage is known as electric potential, or sometimes you'll see it as potential difference. Potential difference. Okay, and that they call it potential difference because if you have a particle here and it wants to go to here, there's a potential difference between this spot and this spot here. It still means the amount of voltage that the field has. So these three ways of saying voltage, well, two other ways of saying voltage being one of the ways, are how you'll sometimes see voltage written. So if you see any of these, it's talking about voltage, and we can think about voltage as the ability to push, to move charged particles. Okay, we'll come back to this voltage stuff when we talk about Ohm's law and starting to move our particles through electric circuits. But for now, that's all I got. I'm exhausted.